Mass m is moving on a horizontal surface of speed v naught. A small box of mass m sits on top of the large box. The coefficients of static and kinetic friction between the two boxes are those two symbols respectively. Find an expression for the shortest distance, d min, in which the large box can stop without the small box slipping. So I drew two pictures for this situation. One just showing those two boxes on top of each other with the acceleration and the velocity pointing in opposite directions since the boxes are slowing down. And then next to it, to the right, is just a free body diagram of smaller box M, which shows that the net force acting on that box is force of friction from static, so that's static force of friction. So since we know that that's going to be the net force, we can we know that's the net force, and we know from the unit that the equation that correlates with that is that coefficient of static friction times normal force. It equals the force of static friction. So that's going to be our net force for this situation for that box of M. So since we know this, we can now just develop a strategy for being able to solve for that minimum distance. So this is a little confusing conceptually, so that's where it took me some time to work this out. So there is some acceleration, there's some maximum magnitude of acceleration since we're decelerating here that correlates with a static friction, a max static friction before the friction converts then into kinetic friction, because if the static friction exceeds a certain value, it will no longer be static friction. It will overcome that and the box will start slipping. So there's basically we're going to try to solve for some acceleration in which the force of static friction will not have exceeded that max. So in order to do that, we can go ahead and say that since we know the net force from the previous part is that coefficient of static friction times normal force, we can set that equal to ma since we know that that's just true based on Newton's second law of motion. And we can replace the normal force with mg just because they cancel each other out, and you can based on that you can solve for n and just find out that we can replace it with mg. And so once you do that, setting those two ma equivalent to the coefficient of static friction times mg, the m's will cancel, giving us that the acceleration is that coefficient of static friction times gravity. So now that we know the acceleration, we can use our kinematics equations in order, due to the fact that they contain that distance element, so we can use one of the kinematics equations and solve for acceleration, or not solve for acceleration, but solve for that distance and plug in this acceleration that we found in order to find this minimum distance. So that's what I did here. Since we know the final velocity is 0, we can just replace that with 0, and then when you solve for distance, you get negative vi squared over 2a, and then once you substitute a, you get negative vi squared over 2 times that coefficient of static friction times gravity, and that'll equal distance, the minimum distance. Here, if you're confused why it's negative, if you were to replace g with negative 9.81, the negatives would cancel. So this is actually, in my situation, going to be a positive displacement. So yeah, that is the answer to this problem. The minimum distance in which the large box can stop without the small box slipping. So, thank you for watching.